Hi guys, welcome to Heat Geek. Interesting episode today. So some of you are aware and others not so much that for me, controls are the number one important thing for heat pumps, way above anything else. And that's why we promote some heat pumps over others, because they have better controls. Generally, third-party controls for heat pumps aren't really very good at all. So we never recommend third-party controls. We only really recommend heat pump controls, heat pump specific controls, because they know how to look after their own heat pumps. However, that's about to change. And that's why today I'm here to introduce you to Karolis from Homely Energy. He's developing a heat pump controller that very much works in the way that we promote on this channel, and even better so, and incorporating more future tech. So he's here to more talk about that. Good to have you here.
Thank you for having me.
No problem. And we're just going to chat the breeze and see what comes out. And also, this is going to be a podcast. So if you don't want to watch this and you want to listen to it in your car, this will be on Spotify and Apple Play. Apple Play?
Apple Music.
Apple Music. I'm not Apple, so...
And all the other places where podcasts are.
Podcasty places. So tune on in. How are you?
I'm good, thanks.
How was your 4-hour drive?
Bit early, but I didn't catch any traffic, so
Awesome.
That's good. Although now I feel like I could have woken up an hour later.
Yeah.
What can you do?
Well, you can drink coffee. So, just a bit of background on you. Where are you from?
Lithuania originally. But the accent, the funny accent, that's from, my dad lives in US. I've got a family there. Whenever I used to go there, they used to make fun of my accent.
Yeah.
And that's why it got a little bit of twang, the European twang.
So Lithuanian mixed with English, mixed with American.
Accent, yes.
Okay, cool.
But I'm still very much Lithuanian.
Right. Okay.
Yeah.
Cool. When did you move to the UK?
When I was 16.
Yeah.
Was
Right.
16.
Yeah.
Wanted to do A levels.
Yeah.
Wanted to go to uni in UK. Realized that the school that I'm at, I'm not going to be able to get into good unis in the UK. So 16 years old, moved to student halls in Manchester to do my A levels, and then went from there.
Amazing. And then you went from there to uni.
To uni.
To study
Economics.
Right. Okay. Nice and thermostatic.
I know, very relatable to the stuff that I'm doing right now. No, so the initial idea was that I wanted to be an investment banker. That was my thing. Was interested in exchange rates and stock markets. It just all seemed very dynamic. It changes all the time. You need to get in so much information. All of the stuff that is happening around us is basically, that's the reflection of what is happening. So that was my initial thing. Did a couple of internships at a really big investment bank in sales and trading. That wasn't really the thing that I realized that I'm going to be able to do. Not in that capacity, at least. So I was spending a lot of time on the commodities desk. But the people that I interacted, the best interactions that I had at the bank were with the quants. So these are the PhD mathematicians that are working on algorithms to trade stuff. And
They're called quants.
They call it quants. Yeah,
Okay, interesting name.
Quantitative.
Right. Yeah.
Quant.
Yeah.
And the thing about them was that they were just so clever, but at the same time so humble. So the people that didn't have the PhDs were a lot less kind of relate. I was not able to relate to them as much as I could to these guys, and these were because they knew so much. They knew as well how much they don't know, I think. That's why they were they would sit you down, they would explain stuff, and I was like, I want to be one of them. So that's when I thought I'll do a PhD.
Okay.
And that's kind of where the whole journey around heating comes in. So wanted to do a PhD in electricity prices, because that's the time that I spent the most on during the internship, and that was really interesting. Looking at how gas flows and how liquefied natural gas, for example, can affect the electricity prices, and how it's all connected, and it's tangible. It's it's a physical thing that you move from one place to the other, and that affects things. That was quite fun.
Yeah.
So I started looking at the electricity prices. Wanted to do that as a PhD. My proposal didn't go through, but the supervisor that I proposed it to was like, "I've got this other PhD that is in maths. Would you like to do it?" Keep in mind that I'm an economist.
Yeah.
I had some training in terms
Yeah.
of like I've done quite a lot of maths through my PhD,
Yeah.
but that not to the level.
PhD level maths.
Not the PhD level maths, and the PhD was in power networks.
Right.
So that meant that I knew a little bit about the electricity networks, but this whole thing was about basically how do we make better use of energy throughout the day. So the topic of the PhD was economic optimization of energy use and storage and its influence on power networks.
Right. Okay.
The concept was basically, and the stuff that my PhD supervisors had was, we don't want to have big jumps in the electricity demand in the UK, and there are these loads of electric heating out there, and they're all turning on at the same time. And can you actually smooth that out if you're giving them price signals? So these heaters, can you smooth out the demand of the electric heating if you give them price signals? As a concept, like that's what I got hooked on, and just as I started, I wanted, one of the things that my supervisors had was this theoretical model that basically this is what you would get if you were to optimize heating in terms of the outside temperatures and the electricity price input. So I was like, I want to check whether that theoretical model works. My parents had a heat pump. They've had it for quite a while, and I was like,
In Lithuania.
in Lithuania,
Right.
yeah. So temperatures going to -20, -25. People that say that heat pumps don't work, they do.
Yeah.
Like that's you have loads of them in those countries like Scandinavia, Lithuania, and they're working at those temperatures, and it's completely fine.
Yeah.
It's a thing that you do because you don't want to get gas into your home.
Yeah.
Like putting a gas pipe to your house doesn't make financial sense.
Yeah. Yeah.
So thought, well, they can't get that mad at me if I break their heat pump. So put a Raspberry Pi together.
Yeah.
And
What heat pump was it?
it's a Chinese one.
Oh, okay.
It's a ground source.
It'll probably be
Lake.
like Nidia originally or something.
I'm not sure. I know that the controller on it was, I think, Siemens, but it was a lake source heat pump. So the actual heat is coming from the lake.
Cool.
That was quite nice for like
Yeah.
efficiency perspective.
Yeah. Yeah.
I think that the unit is quite old. I'd probably suggest them
The-
replacing it.
So the lake would have been frozen up anyway quite regularly for that sort of.
No, because it's only the top of the lake that freezes up, and as
Yeah.
long
Oh,
as
which
it's-
actually insulates the rest, though, I guess. Does it?
Yeah, so
Right.
at the bottom of the lake,
Amazing.
you always have like 6-7 degrees, I think, coming in.
Cool.
And that's constant throughout the year. So
Oh wow.
basically, cops are fairly decent.
Yeah.
And that's the unit that I first started off. So yeah, the whole house was wired with sensors, and basically me trying
Amazing.
to figure out whether the stuff that I got as theoretical models worked. They didn't.
What year was this?
This was 2015.
Okay.
2015, 2016.
Yeah.
Because I had to do, as well as part of that PhD, I had to do like courses in it was master's courses in power electronics.
Yeah.
As in, like, we were looking into wind farms. We were doing some stuff around. It was quite cool. At the time when I was doing it, I never thought that I will need to know what a resistor or a capacitor or an electrical circuit is. Little did I know that a couple of years down the line, I'm going to be building this stuff. But yeah, so the first year, like 9 months was that. And then I started to properly get into the PhD, built the Raspberry Pi, tested it out, and then realized that the theoretical model wasn't explaining the dynamics of the house quite well, but the concepts, as in, it was okay to explain what is going to be happening with the grid. So we continued working on that in terms of the PhD, but then I took a side thing to kind of, well, I'm actually quite interested how close can I get this, and how close can I get all these algorithms to relate to what is actually happening in the real world. And that was kind of like a side project that I started doing from the beginning. And that's when Homely came about. So 2018, decided to had a system worked out that was kind of like, oh, this is starting to make sense. Looked at a lot of research, and using energy when it's cheaper, it's not a new concept. Like, it's been done loads of times in the past. Economy 7, for example, and storage heaters, that was the same thing. So I've never claimed that we were doing something, that basically out of this world, reinventing something. But at the same time, not a lot of stuff has been commercialized in terms of heat pump control and thermostats that understand that heat pumps work in a different way than other systems, where flow temperatures have a massive influence on the efficiency. And this is where kind of Homely came about. So we, from the very outset, wanted to make sure that, and as part of the PhD as well, what we realized very early on is that and at the time when the gas and electricity price differential was still quite big, so in terms of financial sense, it didn't really make one installing a heat pump. That has changed now, and it's hopefully going to continue to change in that direction, where we don't see, for example, people that are using electric renewable heating getting penalized with the additional charges on the electricity price. But one of those things to make the heat pump running costs lower was to actually utilize electricity tariffs, and Octopus Agile was just coming into full swing in terms of kind of, if you can shift your consumption around, you can make some decent savings. Like some of our customers on Twitter were saying that they were making 30% savings on the running costs of heat pumps. And I think that that's the bit where kind of, if you can reduce that cost of running cost of the heat pump, like the operational cost, you can make people more comfortable with the heat pump technology, which again is not new. And then that can see the widespread uptake of heat pumps, which is what we all want.
And the conservation of energy, like, we're going to be looking after the grid. I mean, so a lot of your focus there was on the cost of energy and capitalising on that. But what obviously really excites me is the fact that you've really tapped into and understood how to utilise flow temperature to maximise efficiency at the right times, and overlaid that between the two things to create the best end product. And you definitely have a very good understanding from our chats before of that low and slow, steady state heating, minimal zoning, all the stuff we teach is kind of integral to running the lowest running costs and inferring that the best COPs relatively. How did you get there through experimentation, research? Did you come across the Heat Geek channel? Like, how did you gather all this information?
So at the very beginning, I have to admit, at the very beginning, I didn't know about Heat Geek. So this was in 2018, and very early on, very early on, we just through data sheets, through just understanding what heat pumps are doing, because the PhD project started off as electric heating. It didn't even consider that it's going to be heat pumps, but COP stuff, and basically the big uptake of heat pumps that we were all planning for. That was basically, I knew that I had to look into this, and that flow temperatures are a big thing in terms of basically how do you reduce those to increase the running time. And at the same time, I mean, the electricity prices was an interesting thing from the operational cost perspective, but at the same time, when the electricity is used by most people, it's going to be more expensive. When it's being produced from sources where they cost a lot, so let's say an open cycle gas turbine. Again, you're going to have to pay for that electricity more. So it's beneficial for the grid, for the heat pumps to be shifted to low cost periods, which are probably going to be more renewable. They are going to be away from the peaks of electricity consumption. And then the main theme of my thesis was that and it doesn't have to be the end customer who's exposed to these electricity prices, but at the end, if there are price signals that are telling these heat pumps how to, if you shift around some of your consumption, it's going to benefit you in the end. That's what you should be doing, and then you can smooth out that demand throughout the day, and you don't you don't have those issues around the networks where people are saying that if we're going to replace all the gas boilers with the heat pumps, basically our grid is going to stop. That's complete nonsense.
And your thinking is like or the theory is, which I know is true theory, or correct, is that you can basically use the building as heat storage. We can, especially if it's a higher thermal mass, obviously, we can chuck more energy in during just before the peak, maybe to override the peak, so we can dip heat generation during the peak, and basically use the house as a battery for heat energy, right?
That's what we normally do. So that means that you don't need to buy an electrical battery, or we have experimented with buffer storage before as well. But
buffer storage was too low volume, isn't it?
So we had some interesting.
Told me that.
We've seen some interesting buffer stores, even over 1,000-liter buffer stores that are used on an oil boiler. We were considering that as well for like the heat load shifting. And even though it brings some benefit, it's not worth amazing. And at the same time, you need a lot of space. You also need to raise the flow temperatures quite high to make sure that you can dump that heat into that store. And then when you're releasing it into the house, but that's the efficiency that you lost out on. In our scenarios, we normally just use the thermal inertia of the house, which is free. It's already there. And if the price differential is good enough, then just utilize that.
Amazing. Like everything, it's really vindicating to hear from an expert. I don't really consider myself an expert, although I probably am.
You are,
to say the same stuff like that we've been. This is just amazing. Like internal wall insulation, for example. It irritates me that people do it because that's like a really useful. Your brickwork is very useful for energy storage. Try and do external where possible, or always. But the overlaying of the efficiency and using house of storage over peaks and troughs is like, that's the future. And then overlaid with weather data, obviously. So if you're going to get higher efficiency, perhaps, and this is the important part, perhaps have the house at a slightly higher temperature during that time to store the heat for when it dips back down, which comes on to my next point. Radiant heating obviously has a much wider comfort band, so you could be comfortable between 19 and 23 or something like that, or 18 and 24 with radiant heating. Radiant heating is lower flow temperatures, underfloor heating, higher flow temperatures or bursts. You have a much smaller comfort range, so you might be comfortable between 20 and 21. So because we're using more radiant heating, low and slow, you notice the internal up and down less anyway. And then I don't know if you've done like psychological kind of tests as well. People may be perhaps more comfortable to have it slightly colder if they know it's costing more. They'll trust the algorithm and they'll go, okay, I'll just put on a jumper if it's cold because I'd rather save the money because I know this is going to turn back up when it's cheaper, right? And that's how it works.
So at the moment, we actually don't jeopardize the...
You don't jeopardize internal temperature.
We don't jeopardize the comfort of the customer.
Right.
So the amount of heating that we can put in and jump through these peak periods is actually enough to get you through. So rather than putting on a jumper, you're probably going to have to take one off.
Okay.
Because you're going to be warmer during the times So let's say that the peak congestion of the network is between 4 and 7 p.m. And that's the peak that you need to jump through with the Agile tariff. That used to be the peak that you need to jump through. The cheap electricity prices are usually just before 4 p.m., between around like 1 and 4.
Right.
And then there is a cheap period overnight. So you dump heat through those periods, and then just before 4 p.m., you're dumping as much as you can, and then you jump through the 3 hours. So when you get back home, you might be a little bit warmer, but that's kind of good because you just got in, just settling. And then once you've jumped through it, the electricity price again jump down. So
okay, right, yeah. So where my misunderstanding there is, obvious now. Your constraints are set by those peak times, which are only like a couple of hours for the peak. So that's all you have to store for. obviously houses of higher thermal mass, Victorian houses, easy peasy, I'm guessing, for elongating that time. New builds, can they jump that gap relatively easy with almost no noticeable?
Yes. So we've not had because the electricity prices have been crazy
Yeah.
the past year.
Yeah.
So we've not had that many
Yeah.
like new customers on Agile. But from what we can see, as in like for majority of the winter, like these houses would be okay to jump through these periods, and it's still so the customer is still fully in control. As in like if they want 21 degrees in the evening and they want 21 degrees in the morning,
Yeah.
that's what they set, and what they provide to us is the flexibility above that.
Yes.
So 21 degrees plus, for example, 2 degrees, and I'm comfortable anywhere between 21 and 23, as long as you're saving me money.
Is there an argument to, because the time constraints kind of answer this in one way, I suppose, but is there an argument to say, and I'm comfortable to -2 degrees from my comfort temperature to, I don't know, allow it to go both ways, or?
Tried that at the beginning.
Oh,
So
right.
we did start off with basically setting the maximum and the minimum and then the set point.
Yeah.
And it's very confusing to explain the set point and the minimum.
Right.
So like, what do you
Well, I
consider
get it.
the set point and what do you consider the minimum?
Yeah.
That is, when you're trying to do these trade-offs, for example, you need to consider kind of how do you value comfort in terms of, if I was to keep you below the set point for an hour, are you like if I was to save you £1, would you be happy? But that's again an additional question that we would need to ask.
Yeah. And here's another one. How are you behind the fight against CO2 production? Because, you know, obviously because the pound, yeah, I might be fine with that, but if I know I've lowered my CO2 footprint by X, you know, I might be more happy. So it's another payoff, I suppose.
True.
It changes per individual.
The trade-off between the cost and the carbon, and that has been brought up to us quite a lot. So one of the things that we, at the moment in the Homely, you can't select basically cost or carbon, and that's...
You can or can't?
You cannot at the moment. So the majority of our customers are actually just the simple, like fixed tariff customers. And what we're trying to do is we're trying to run the heat pump in the most efficient way possible. So you're that perfect weather comp that that's the reason why we got in touch with you guys, is because you guys are selling the same story. Like it's very nice to see other people kind of trying to spread the same thing, that we are trying to run the heat pump for as long as we can. At the lowest flow temperatures.
No one-off controls.
No zonal controls. Basically, just the whole house. Let it run. The heat pump should just be plodding in the background. Slow and steady wins the race. The same kind of thing, and that's why we got in touch. That's why. And when I saw a couple of your videos, that was like, we need to speak to this guy, and we need to. We're selling the same story, and
I like the fact that you've come from a practical background though, and experimental testing. All of my stuff is, actually, I was going to say all my stuff is theory. All the theories I explain are thought experiments with theory. However, I've been installing this way for over 10 years, like open circuits, weather compensation on boilers. I'm new to heat pumps, but my expertise would be controls, because that's all I've been doing and talking about and playing with parameters and hydronics. And that's an important thing to understand as well. We often get asked, I get messages quite regularly from electricians saying, do you think I should go and do like the Heat Geek course or whatever, because then I'll learn how to set up the controls. The hydronics and the controls are interlinked. You have to understand both sides. The person commissioning should be the person who was there for the hydronics. You can't disjoint that thing. The controls, Karolis is talking about, Homely does work in a certain way, and you should understand that in order to design your system to the most effectiveness. Anyway, sorry, slight tangent. Cool. So, like, do you guys, do you look at, well, first of all, you intelligently connect to the heat pump, right? So via Modbus?
Yeah. So,
right. So you can send demand signals like flow temperature to, and read information such as compressor speed off the heat pump, right?
Yeah.
And then you analyze that data, you look at cycles, etc., and you try and elongate cycling.
So the way that it works is Yes, we're connecting through Modbus, which is very similar to, I don't know, for those that are comfortable with
Open
boilers,
therm.
Open therm, yeah, open therm. And we get different heat pumps give us different level of basically information.
I'm just going to pause you for a second. Open therm should not ever be allowed on heat pumps because the open therm controls out there are just not very good for heat pumps. They're too jumpy in flow temperature, and it would be too easy for, say, a consumer to go and connect one in and just like ruin their heat pump efficiency. If the standard is set to a new standard, perhaps it should be opened up later on, but we need to prove the standard first, and you're leading the way there. Sorry, had to make that point. Carry on.
No, yeah. So we've, as a concept, it's very similar. That we are trying, instead of going for the on and off controls, we're sending the flow temperature, like a flow temperature set point to the heat pump, and then
as you see with gas boilers as well.
Yep. If you were to stand right next to the heat pump, you would just see that flow temperature set point changing every half an hour, and that is us basically just doing that constantly. So what we say is that it's Homely is kind of like the installer sitting there, basically doing that 24/7 and changing that weather comp. So the first thing that we do is Homely gets installed, Homely gets connected into the heat pump, and it's not difficult. Basically, 2 cables that are going into the heat pump. So we install the Homely, and then it works on what we call default parameters. As in, like we know some models of houses that kind of work for houses in the UK. So they're not perfect. Basically, we don't know exactly how long it takes for the house to heat up and cool down.
Right.
But it has to start off somewhere.
Yeah.
So the first couple of weeks with Homely is basically Homely learning. So and what Homely is trying to do.
Should you be telling people this? It sounds like really good information. You're pretty so far ahead. It doesn't matter now, I guess.
I mean, it's basic concepts. As in, like, I'm not. It's.
I'm kind of teasing.
I thought that this was all for TV. That's why I've answered seriously. So what we need to understand about the house is basically the heat loss of the house. So I'll try to put in the things that we all do. So the heat loss of the house, when you're doing the heat pump installation, we all understand how important it is to do the calculations right. And this is basically Homely. When you install it, it's looking at the internal temperature, and then it's looking at the heat output of the heat pump, because we can get that from the heat pump itself. As basically the heat pump is telling us that I'm putting in this amount of heat into the house, or you can just calculate it from the flow rate, the flow temperature, and the return temperature. So once we know basically that this is the heat that is coming into the house, and this is how it's affecting the internal temperature, then we can build this kind of image, like a digital image of the house, where basically it tells us how long this house takes to heat up, cool down, and also how much heat does it need to maintain that temperature.
It works out the relationship between the surface area of the radiator versus the heat loss of the property. That's the key relationship, right?
Yes. Yeah.
And then added into that, thermal inertia, i.e. Thermal mass, because that's the speed at which the heat leaves the house, which is 2 different things.
Yeah. But once we've learned how that house behaves, then we can do some clever stuff with it. So then we can, once we know that given this outside temperature, you're going to be losing this amount of heat, so the heat pump needs to run at a certain flow temperature. Then we can basically overlay this. So this is your house. We've learned it now, and then every day, basically twice a day, we do optimizations, and in those optimizations, we're looking at the weather predictions. So what is the outside temperature going to do for the next day? And also what the solar predictions will do. So one of the really cool things that we were looking into is on the corner months of the year, and it's not so important throughout the winter, but on the corner months of the year, when you start getting a little bit of solar gains through your windows, that makes such a massive difference in terms of how much heat you need to be putting into the house. So if you were to just do it on a simple outside temperature, you might not capture that. Whereas with our system, so let's say that you're losing, I don't know, 2 kilowatts at 15 degrees outside, because you're keeping your indoor temperature very warm. But at the same time, so that's the heat loss of the house if it was a cloudy day. But if you had solar basically putting in
Yes.
half a kilowatt,
Yes.
you only need 1.5 kilowatts from a heat pump.
Yeah.
So that's something that we can also take into account. And the way that we do that, and it's pretty cool, is that when we're learning about the house, we then kind of rotate it around
Yes,
because we know how much sun is going to be coming in.
What time of day versus the weather that time of day versus which way it's facing. Amazing.
Yeah. And all of like once we've rotated it, we kind of know that this is the house, this is the direction of the room,
the windows or whatever.
And that can tell us basically that for the day ahead, if we know that there's going to be loads of solar gains into the house,
Don't bother ramping up.
don't bother ramping up. This is especially important if you have tariffs. So I'm one of those smug people that managed to get the Intelligent Octopus when it was still 5p during the night and 24p throughout the day.
I would have assumed so anyway, but yeah.
The problem there comes in, and if you're not accounting for the solar gains, you might see that okay, it's 15 degrees outside. I've got a set point of 20 degrees, and I want to just overheat my house slightly so that basically I can jump through a majority of the day without heating it.
Yes.
So let's say up to 1 degree.
Yeah.
In this scenario, it might be that I only need to overheat it by half a degree, because basically after my cheap period, a couple of hours later, the sun is going to come out, and that's going to heat me for the rest of the day.
Yeah.
So Homely would understand that and basically anticipate that solar gains are going to be coming in, and you don't need to heat as much. So that's one thing. Weather predictions, again, one of the other things, like without weather predictions, we wouldn't know how much heat you need to dump into the house.
Yeah.
So it's very important when you're trying to look at and this is kind of future-proof Homely, that the customers right now, even though they have a fixed tariff where they want the heat pump to be running in the perfect kind of weather comp mode. And that's what we can deliver. We can deliver that for the heat pumps that we integrate with. And in addition to that, you're also protected against that kind of future where everything is going. So like the demand side response.
Exactly.
Shift time.
Amazing.
Shifting.
Yeah.
And from the customer as well, the app is kind of super simple. So none of the stuff.
Well, you see, they shouldn't be interacting. Any decent controls, if they're good, like people talk about, is the interface any good? You shouldn't know. Good controls, you shouldn't have to touch. That's the important thing, right? Like if you're having to go to controls to adjust all the time, you've not got a good control. It doesn't matter how good the interface is.
That's I very much agree. So in terms of the app, once you've set it up, you shouldn't be able to. You shouldn't need to touch it. The app, I mean, we do give because we're trying to take on a role as well of educating people like around how the heat pump works. So for the end customer to actually explain why the heat pump is doing a certain thing, because I mean I can completely understand that if you're heating the house in the middle of the night and you don't have a set point for the next 8 hours, like it might seem quite strange that why is the heat pump running in the middle of the night when I don't need heat till the morning, and it's 20 degrees and I have a set point of 18 in the morning.
Just send them to the Heat Geek video. Should I continue to heat my home? It's covered all of this. We're done.
I know that's why.
Pop the video on your website.
That's why we got in touch, and that's like in the app there are these like things that you go and read about this, and it does make sense, and just to give them the reassurance that it is doing the right thing, kind of like that. It doesn't worry you basically. That's not working. When you go onto the app, there is a little bit of info there that it's working as it should do.
All of that's like, it's amazing. So people may have heard me mention before that I don't like interference from zoning or any kind of clever controls trying to do anything. The key difference here with what Karolis is doing with Homely is it's not on-off signaling and just looking at just the room temperature as being the place that you get efficiency. This is what like Nest do with their on-off controls, or any of the others that have PIR sensing and stuff like that. They're only looking at, okay, how can we minimize heat loss? Minimizing heat loss is different from minimizing the primary energy into the house. We cover this in one of our videos called probably is on should I heat my home consistently or not. But the difference is this understanding, hence he's affecting flow temperature only. So although he may know that, right, we need to have the house cooler now, he's not stopping heating, he's continuing flow, just lowering flow temperature in anticipation, proactive to whatever event is going to occur. And bear in mind, they'll probably coincide, so let's say it's solar gain, he'll lower flow temperature, and the house will take a while to start to try to cool, but that should time with the solar gain, right, anyway. And so, there is so much to do here. I'm definitely aware of and open to and excited about the fact that AI, essentially what we're doing here, right, can improve our efficiencies and SCOPs. So I do want this kind of integration. I think it's amazing. I've been waiting for something or someone to start doing it. And I think you're doing it. It's awesome. Have you found any interesting tidbits about heat pumps? What do you think? Cycling, you were talking about that earlier on. We were comparing cycling notes. I mean, mine cycles. These could be defrosts. I'm not sure.
6 degrees outside.
6 degrees outside there. It's got, what's this? This is that's 10 to 1 till 1:33. It's a 40-minute cycle, then a blip off. I guess that might be a defrost.
But at 6 degrees outside.
No, that's just a cycle, actually. Yeah. That's just a cycle.
Adam, can you just tell us what you're looking at for the audio listeners?
Sorry, we're looking at the graph of our property here. The property here being our offices. We have no loft insulation, no cavity insulation, and 4 blown windows. And the window we're looking at the moment is a COP of 4.29. Actually, what I'll do is I'm just going to record this. How do we record screen? Is it that one? Well, that's video. Can I turn it to record? Record. Just record inside screen.
That is, so I'll make a point about balancing.
Yeah.
Because if we are seeing basically the heat pump basically pulling down in terms of not able to run at very low capacity, that usually identifies to us that it might be that some of the radiators are closed. Or balancing.
It's not the case here. Don't offend me.
I know. But no, the balancing is
yeah, of course. Yeah.
For the customers. So we've seen that, and we're going to be using heat cameras to actually see whether all the radiators are getting to a decent temperature. It makes such a huge difference.
I think that we should fit smart radiator thermostats, but not to control the to see if we can monitor flow and room temperature and flow temperature at because it might be a big drop off in flow temperature. There's other stuff other data points we can get from there, but not in the way they're being used at the moment, which is on off, all that craziness. And I do think as well, I would add, there might be some argument for zoning in more in the shoulder months. So if you look at we might make this point for a while, so I'm saying it now. If you look at our why not to zone heat pumps video, you'll see we do a calculation for when it's -3 outside. We zone it, then we don't zone it. So we zone it in the calculation, then we unzone it, and you use much less energy when it's not zoned. If you do that same calculation when it's 12 degrees outside, actually it's more efficient to zone. However, you have to overlay that with potential heat pump cycling. It might be cycling in the shoulder months anyway, so if you zone, it's going to cycle further. However, there might be capacity for this room to be 20 and that room to be 19.5, fine amounts of playing around. Or if there's solar gain on one side, not on the other. Do you know what I mean? Tiny amounts. Who knows? Unless we do it.
Solar gains. So yeah, solar gains is one of the things. Yeah, if you were to use them, and that was your video. So thermostats as temperature limiters. Yes. That could be used basically. That you just put you've got a room that is exposed to sun and basically gets really, really warm. Yeah. So it's uncomfortably warm, and basically you want to close off that loop. And it's only basically when the sun comes out. Then you could leave your thermostat in that room, but you need to make sure that you're careful about setting it higher than what you actually want the room to be, so that it doesn't keep on closing it off and opening it back on.
Exactly. We want flow. Yeah.
We want we want volume, we want flow, and we want to make sure that we're using as much of that heat emitter area throughout the house as we can to get the flow temperatures as low as we can.
The TRVs, I'm imagining, they're off, still has an opening that allows, there's always flow. Like, it just puts on brakes to a certain level. Like, do you know what I mean?
Well,
you have to allow flow everywhere. You have to.
It's the flow, but also the emitter area. So I think it was very interesting to see your video about the zoning. You know, when you were drawing the things, like how the warmer rooms are heating the rooms that are cooler.
Yes. B-roll.
Before I've seen that, I've done internally. Basically, we were looking into the zoning thing because we're doing a lot of installations and we were doing these kind of just internal explanation of zoning. Like, does it make sense, and should you do it? And the interesting thing is that I've just basic physics, basically, that you've got U values. Got it here. So for the listeners, I'm gonna try to explain what we're looking on the screen. So actually, just before I do this, one thing that I wanted to show is, in terms of the homely operation, and some stuff that we can actually share in terms of graphs and calculations.
This is amazing, by the way, isn't it? This is really good. Like, everything this is awesome. Sorry, carry on.
So this is how our smart mode would work, and it's a theoretical house, basically. But the good thing about the stuff that I'm showing on the screen right now, and I'll explain it to those that are listening on the podcast, is that we can share the maths behind it, and we can actually show people why this would make sense.
Yes.
And then to just add some credibility to it, we have some real data to support it as well. Basically, where Homely is working in the way that we've said in the theoretical example.
Yes.
So this is not the full Homely algorithm, but it explains them like the important concepts around it.
Right.
So I can share the data behind it. I can share the spreadsheets. Basically, what you can see here in the graph is that you can see the internal temperature, the set points of the house, the heat pump and the outdoor the heat pump operation and the outdoor temperatures. Important things to note is that, let's say you have a 20-degree set point for the evening, and then 18-degree set point in the morning. A lot of the time, what I think a lot of people would agree on heat pumps is that you shouldn't have these differences in set points. And basically you should just run it continuously throughout the day. That's what the weather compensation, if you were to just set up as the same temperature, would do. With Homely, we do take into account a lot of these factors, and it might be that on one day we will decide that it just makes more sense to run you continuously throughout the day for that set point in the evening, so 20 degrees. And even though you are at 20 degrees at, in the morning, 8 o'clock, 10 o'clock, the heat pump is still going to be running in the background, maintaining 20 degrees, which again is the bit where we are trying, through our Homely app, we're trying to explain that this is why we're doing that. We know that we're doing this, and it just makes sense because of certain factors. In this example over here, what you can see is that these bars, they're out of scale on purpose. They just consider them when the heat pump basically is on. And there's a period in the middle of the night when the heat pump turns off for a few brief periods. And that is because the outside temperature drops quite low. So it doesn't make sense anymore to even run it at low flow temperatures. But if you look at it here, so our set point of 18 degrees or 19, I don't actually remember what's in the thing there. At 8 o'clock, let's say that it's 18 degrees. Your heat pump is running at 12 o'clock, at 1 o'clock. It then turns off at 2 and 3 when the outside temperature, let's say, drops to 1 or 0. And then it turns back on at 4, 5, 6, 7, 8 o'clock in the morning, and maintains that kind of like very low flow temperature. So it's like landing a plane. You can see there, like slowly.
Very good. Yeah, that's a good analogy. I like that. But importantly, you can have heat pump on and a gentle heat going in the property and have the property reducing in temperature. That's the whole idea. We're still feeding the thermal mass of the walls. We're still keeping the water hot, etc., etc. So when it does come back on, it doesn't need to go whoosh.
Yes, and as much as you can see in this scenario, so that's like the 2 periods where you are actually off. So out of the whole night, the heat pump the algorithm does decide that at the moment actually it does make sense for me to not run.
Yeah.
And this could be, for example, that the COP drops so low that it makes more sense for you to just wait a little bit and then slowly ramp up those flow temperatures again.
Yes.
And what you can see here as well, so that slowly lands you to the set point of the morning, and then throughout the day you can see that the heat pump is ramping up again towards the set point in the evening. So it's like it's like taking off the plane. Basically, slowly and steadily, low flow temperatures, slightly ramping up those set points.
I kind of get where you're going with this, like, as in just even the explanation and the app stuff. Just stop second guessing what they're doing and just trust them to do it. Basically, I can see your sort of predicament of customers questioning why and what, but they kind of need to understand this theory, right?
Yeah, and this is I'm only going to show this. I don't think that people need to understand what's in that graph right now.
Yeah.
But it basically just shows one of our directors. That's his house. Real data, basically. He's on our mode with smart tariff, and there's some stuff here. But the important bit to look at is that these are our flow temperature set points.
Yeah.
And you can see how the internal temperature is slowly ramping up towards the set point of the evening of 22 degrees.
Yes.
And the flow temperatures are slightly reducing here.
Yes.
And it gets to, I don't even know, like that's probably like at 10 degrees outside. He was probably running at like 39 flow.
Yeah.
Radiators.
Yeah.
So the concepts that we're showing basically, and that we're talking from Homely's perspective, this is real world data basically showing you that it does actually work in that way. And this is just one example of many. Like the houses, like we have this dashboard where people can, as an installer, and installers are very.
The installers get access to a dashboard like this that shows flow temperatures and stuff. And
yes.
Is this taken from the heat pumps data?
Yeah.
Right. Okay. So do you use the heat pump air temperature sensor in the heat pump, or is it if there's an external one connected as well?
We can see the internal. We can see the outside temperature sensor of the heat pump, but we use the weather station data because that's
you found that to be
that proves to be a little bit more. A little bit better in controlling the internal temperature, so a steady, more steady control of the internal temperature. It was an interesting thing that we found.
Because it goes against my thinking.
But for some reason, it made it a lot more smoother.
Yeah.
Okay.
And, that's the evidence. That's the evidence. Cool.
And it's also that when we're learning about the house. We need to be using the same information for our predictions as well as.
I don't know. I'd assume that you might perhaps, and you're not there yet, and you might do it. Overlay those pieces of information. You might find that might be more accurate here, and etc. That's what you've done.
That's the overlaid information from the heat pump, so you can see that the predictions of weather surprisingly good.
What is the range there? Okay, like a degree or something. Cool.
So you're looking at -4 here. That's -3.44 from our weather forecasting. And it's important to because we're doing predictions on using certain data. We want to make sure that we do the learning on the certain.
Did you not find that some areas aren't near a local weather station, so their predictions are less accurate than others? Therefore, you might want to push more towards the local sensor.
Yeah.
Or between the two. I don't know.
Sometimes they do happen, but the Homely algorithm as well, it's not just based on the outside temperatures. So we're constantly taking readings of the internal temperature. And
I'm just so fixated on weather compensation. That's all I think about. Flow temperature and outside temperature.
I know what you mean. And yes, sometimes they don't align as well. I've not actually picked this one like on purpose, but they don't sometimes align as good as this.
Yeah.
But they're usually fairly close. And in terms of the internal temperature comfort, like if you can, this dashboard basically you can show, you can see that the internal temperature is basically within 0.23,
Yeah.
0.3
Yeah.
degrees at max
Yeah.
of the set point.
Cool. We let ours drift around, to be honest, because I'm such a purist with weather compensation. Also, we have like internal gains because we fill up upstairs, we empty upstairs. Ours jumps up and down. It doesn't go below 20, but it's like 20 to 22. But that's fine. Like, we could and maybe should turn on some sort of room influence, maybe. But I'm just such a purist. I like pure weather compensation.
That's kind of like this is taking into account the indoor temperature, so it's the internal temperature influence with the thing that you're talking about.
Yeah.
But yeah, this dashboard thing. So it wasn't supposed to be released. We were using it internally.
Right. Okay.
Basically our own.
But it helps educate,
installs.
right? So.
It helps educate. It helps us like if there is an issue with the heat pump and we don't want to go just to the heat pump just to figure out what the issue is. We were able to use this dashboard, and it was always the idea that we're going to make this nice and pretty, and basically we'll put a lot of effort into making it the real product.
Yeah.
We've been so focused on the customer side of things that this kind of hasn't gotten the attention that it needs.
It's a really good point, actually, because if you get installers on site, you won't need to explain to the customer. That will literally be the installer's job, and they'll say, look, you'll find that the controller will do this, it will do that, but this is all normal, these are the reasons why. Your message is delivered for you. I think there's a natural desire for any commercial company, obviously, to pitch to the consumer, but the key into a home is through an installer. From my background,
very much agree. That's why a lot of the stuff that we're building and a lot of the stuff, the customer experience is one thing. The algorithms is like something that we're really proud of.
Yeah.
The app on the installer side is something that we've spent probably the most time. Like the apps is the thing that we spend the most time on. So making sure that the Homely is as easy to install as it can be.
Yeah.
And we've been doing a lot of like all the feedback that we're receiving, and we're constantly improving the product and trying.
So this is like V2, 3.
So the actual hardware, is the V1. So
I suppose, because everything else is so many it's constantly being updated. Like,
you would
where do you think? So say finished. I know that's never a thing, but like, where are you on the? I don't know. Are you a quarter of the way?
I think we're at we have been at the point where we're confident in what Homely does for the customer, and that we can see confidently Homely works the way that it should for the end customer in terms of smoothing out the kind of the installer experience, and that's only at the point of the installation. So when we're doing training, we do. Them.
You say install experience. It's bus cables, right? So more bus power.
Yeah. Well, you need to connect it to Wi-Fi. You need to connect it to the temperature sensor.
Right, of course.
And there's wireless stuff. Yeah. So installers kind of experience that you want to go in, install this, and go out in 20 minutes. 10, 20 minutes. And I think that at this point I could do it in like 15.
Yeah.
We can try it.
I'll push back. So there's what installers do currently. And there's what installers should be doing. And I think there is a change there and a growth to be had. I think as installers start to take charge of and understand that they're part of this big change, and make it quicker is always a good thing, obviously. So carry on doing that. But I would say, like, don't get too caught up on where they are, because installers, as a whole, do need to change their habits. And that's what our channel's about, stay with the customer. And
handover.
Exactly. Handover, explanation. Handover, basically. Yeah, exactly that.
It is very important, and it's something that we are trying to do. We're trying to spend quite a lot of time on thinking, as in like, how do we, at the same time, so for the installer, and understanding how busy they are, and how much stuff they have to do, and how much, at the point of when you're doing the installation of a heat pump, it's quite a lot of stuff happening at the same time. The customer gets overloaded with information.
Yeah.
And sometimes, like at the end of this
Yes.
install,
Yes.
it's a Friday evening. You want
Absolutely.
to get back to your family as an installer.
And importantly, if we're going to put a heat pump in every home, each heating engineer will need to do about 4 days' work each day. So you need to try and reduce that amount of time.
It's it's a lot of effort. So when I said 15 minutes, isn't like the installation of the home, it could take 15 minutes. But one of the things that we're at the moment trying to like get together is trying to figure out how that onboarding could be done through different means. So we have guides, for example, where people can read, but sometimes they might not be interested in guides because that's not the way that they take in information.
Yeah.
It might be videos that are better, and then the installer doesn't need to kind of spend as much time walking the customer through. As you're going through the app as well, as in like the initial experience of the customer, it's all being basically the app itself does the walkthrough through the app and basically
with you.
what information you want to be explaining, so that it takes a little bit of that. As much as I appreciate
what you're saying is 100% correct. That should be a thing. How we operate needs to change, and there's probably multiple ways it needs to change. The installer needs to understand what's going to be said there, so the messages align.
Yeah, definitely. So that's why you can't install a Homely before you've done the training.
The Heat Geek course. Wow.
Before you've done the training, well, it could be part of the Heat Geek course. I don't know. We'll see. But yeah, we want to make sure that the installer understands how the system is going to operate, so they can confidently say to the customer, and if the customer calls them up, which hopefully doesn't happen because Homely app explains basically that the heat pump is working in the background, it's all okay. At the end, basically the installer can say that don't worry, slow and steady wins the race. Basically, just leave it running. It'll do the right thing, and from the installer's perspective, they'll be able to see that the systems are running. So dashboard, you were asking before, do installers get access to dashboard? I went into this really long story about dashboard. Main point being that dashboard is available to installers, but they need to understand that this is not a finished product, and in no way this is a reflection of what Homely does in the background.
Right.
So we spent a lot of time on the installer app, on the customer app, on the actual product itself in terms of algorithms. Dashboard is something that is going to be done. There will be a very nice version of it, but installers basically said some of the installers, when they oversaw us using it, they were like, can I get access to that? And we're like, well, it's not a finished product. And they were like, I don't care. That is useful for me right now. So some of the stuff that you can see here on the dashboard, for example, is the calculations of the COPs, the information from the heat pump itself, like the compressor frequencies.
I mean, fault finding, fine tuning. There's lots of things there. So installers will still be able to go and play around with the normal parameters for the heat pump, or would you literally? It's every parameter that could be accessible. You guys can and do. Actually, it doesn't really matter what the parameters are, does it? Because actually, you're just giving it the flow temperature. All right, cool.
You don't need. So
it takes the brains from there and it just uses those brains, and then losing internet signal.
Not a problem. So you do want to reinstate the signal for the internet as soon as you can. But if you lose internet signal, what is going to happen is that Homely is just going to continue working in the background for basically on the schedule that you've set up before. You can also do local boost. Buttons and
an intelligent thermostat.
You wouldn't feel that much of a difference. I mean, how much do your schedules change between days? And outside temperatures might change. So basically, you need to make sure that you reconnect it as soon as you can. But it's not an issue if it goes off.
What kind of are you guys seeing, like higher efficiencies than like other typical normal controls, or like your SCOPs higher?
So it's really difficult to do. One thing that we've been asked is basically, okay, can you just put one? Can you do 2 days, for example, 1 day with Homely and the other day without the Homely?
Different weather, different humidity.
It doesn't really work that way. We do have some testing planned in controlled conditions where we can control everything, and we'll be able to share that.
Where has that been?
So Salford University,
Oh, yeah, cool.
we've won one of the projects, one of the heat pump ready.
Can I set up the other controller
Might be able
and
to.
record it?
You might be able to, but I mean,
Well, and if it doesn't go well, we just won't show it. I'm joking. I mean, I'll put it out there. Like, I'd like to set up the other controller. That'd be good.
yeah, we can. I mean, we can discuss that. The testing plan is. It's a little bit, but we've had to come up with a testing plan, and it's set, but I'm pretty sure that we can, like, if that gives more confidence to people about what Homely does.
Here's what I think. I think that this is my prediction. If we go head to head, we will be able to match cops, but you will be able to run cheaper. That would be my kind of thing.
If you were to set up the
Scops. So if I set the controller, the way I set the controller, it's basic weather compensation, nothing like clever really. Might look at the run times, etc., or cycle rates. I think that our scops might read equal on the screen. Maybe it's some slight difference either way, but you would have ran at a used less expensive electricity essentially. So ran cheaper. That's what that'd be my guess. Because when you ramp down because you know you're getting the summer thing, ours would be continuously running, but it will get that higher scop, which would bump the scop up, but that would be, not necessarily a great thing to do because you're going to be losing some heat or whatever. So that would be my assumption.
I think, well, it would be interesting. So again,
Or do you think that we'd be at, like, can the computer beat?
I'm pretty sure that
Yeah.
I'm very confident that we would
Cool.
be okay. I'm just
Great.
I'm just not
So you think
sure.
you'd be able to get better scop and lower running costs?
It depends. So
Which sounds like it would be the same thing, but you understand what I mean conceptually, right?
So if in terms of if you have a customer on fixed rate tariff, basically the tariff doesn't change throughout the day.
Okay.
So let's
Then
assume
it's
that
just scop. Right?
let's assume that basically we're trying to work on scop. Are you using internal temperature feedback or no?
It depends on the building and the user type.
So
less so if it's higher thermal mass and less windows and less prone to solar gain and high heat loss, use less internal reference. And also it depends on the controller, because some controllers, this is what makes a good controller for me, which you don't need to worry about, is an adjustable room sensor feedback. So if we've got a house that has thermal mass, but there is a one window that lets more heat in or something like that, we'll have a little bit of internal feedback that just shifts it off the weather curve. And if it's got loads of glass on that wall and timber frame internal walls, no thermal mass, we turn the internal reference up, and then we try and have it as low as possible without the comfort suffering. Does that make sense?
And how much? So in terms of like, how much do you adjust those, and how much of a trial and error that is?
Like 1 or 2 times, nothing crazy. I said educated guess because I've been doing it for 10 years.
This
is mainly Wiesmann controls. Now,
this is where, if the Wiesmann was there, if the customer had a fixed rate tariff, and if he had internal temperature reference, we would be working on the difference between the Homely and what you're going to do would be marginal, as in like probably, very, 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 very small.
Yeah.
But
let's
why I teased it.
That's the best controller in the world by far. That doesn't mean it's like amazing. Like, well, it is pretty good, but you can do that to any heat pump because the other heat pumps aren't there. Like, you get the best controller in the world put on any heat pump,
and you don't need to do it.
And you don't spend ridiculous amounts of money on a Wiesmann.
And you don't need to spend it like you said. The reason why I was teasing it basically, how many times do you need to go for trial and error?
Oh yeah, and you don't have to adjust.
You don't need to adjust that. So that's basically for a fixed.
I mean, it's a little bit shameful, but I'd probably just do it on the first visit, and I'd know. And so it'd be well, actually, I'll tell you my process, and actually, so this does work in your favour. Internal reference off. Mm-hmm. Curtains drawn on any solar gains.
Yeah.
Get weather compensation curve in over a few days. Happy with the compensation curve? Yep. Then, we've seen during these days how much the room temperature changes. So therefore, we're going to put room influence on X. Does that make sense?
Yeah.
So that's what we typically do.
And that's all
So that's, I mean, if the customer's there, that might be a phone call. So yeah, if the customer's more knowledgeable, I would just talk the customer through which parameters. I know them anyway. But yeah, well, we wouldn't need to do any of that.
That's half an hour.
Yep.
Like half an hour a couple of times
Yeah.
after the visit.
Well, I can't put on a homely on a V-Smooth, can I?
Not at the moment, no.
Are they likely to be able to?
Not sure. It's one of those conversations that we, because they've not been, we've tried to focus on the heat pumps that are popular
Yeah.
in the UK.
Yeah.
Viessmann is
Less so.
less so.
Yeah.
Um,
And Valent is not ready. It doesn't. It has the Modbus card or something, and it isn't enabled or something like that. Is that right? I don't know.
I'm not sure whether they have a Modbus. I think they've got a different protocol, which is called eBus.
Yeah, they have eBus, but I think there's also like a Modbus port that's like mysterious and unused. This is what I've heard. Yeah, well, that's what I thought. I don't know.
I've spoken to them a few times, and they're really like Valent is a really cool company, and they're really cool guys, and the units are good. But yeah, for our integration, basically, that wasn't a simple integration. We could, in the future, for example, try to interact it through eBus, even if the Modbus adapter wasn't there. But at the moment, that's not the route.
They are changing to a different bus soon. Anyway, I don't know how much I can say about that. So,
Whichever way it is, if we can read some of the information from the unit and control it.
Importantly then, so Samsung, Hitachi, Mitsubishi.
So Samsung,
Yep.
Midea,
Yep.
these are the two that are currently on our website.
Yeah, they're the main ones installed anyway, right? Apart from Daikin.
So we do have integrations that are gonna. We integrated with these heat pumps, but we've not prepared the installer resources.
Right.
So we know that they work. It's just that the installer resources are not there. So we've not released them so that everyone basically could get it, because we want to make sure that, again, it comes back to that. You want to make sure that it's installed correctly from the very outset, so that the customer gets top level experience from the very outset. Because if you're gonna, if at the point of the installation something goes wrong, it's not great for the installer, because they're gonna have they're not gonna consider homely like a product that they want to install, and also from the customer, if they get a bad experience at the very beginning, it might be hard to regain that trust of the customer. That's why we've done the integrations, like basically that we can control these units, but we've not prepared the installation manuals. Like we've been preparing them, but they're not released yet.
Grant, are manufactured by a company called Chofu. It's rebadged. Do you know if
that does have a Modbus that is available.
Ken, one of the guys at Vito upstairs, has one of those, and the Grant controls are what they are. Do you think we can? Because he's got sensors all over his kit, like his. Can we swap it out? And I know it's different weather, and we'll have to account for the humidity, all the rest of it. Can we swap it out and have a little look at what it does to his? Because I think that's his solution. Like,
we need to. So there's a bit of integration work.
Yeah.
So our hardware.
Yeah.
Basically, we need to. Every single heat pump has its own quirks, has its own registers. So
which you're learning and compiling all the time. So you opening up your what you can fit on, right?
Yes.
Right.
So for example, Samsung, Midea, LG, Daikin. For these heat pumps, we already have a Modbus
format
interface, and basically the protocol is all worked out. For Grant and any new ones, we just need to spend a little bit of time basically getting connected to the unit.
I mean, he'll be a good person to work with anyway.
We want
Ken Bone, right? I mean, he's on.
So we know Ken. Ken used Homely, but he's taken it off because he wanted to do it himself.
He does do it himself, but did he use that on his last heat pump?
Samsung.
Right, he's got a Grant now. Oh, well, that's what I was going to ask him. He may say that, but I don't mind getting on camera. That's cool. He likes to program it himself to control it.
So that's why Ken was working with Leah.
Yeah.
For NG Your Way.
Yeah.
And they were installing Samsungs, and some of them had Homely.
He's tried to get us to install them. But Samsung controls. Oh, right, Samsung with Homeleys. Is that what we're doing every install with Samsung Homely?
I'm not. Yeah, I don't think that it's
Well,
every
because
install.
you shouldn't use Samsung controls.
But so your energy your way. I know that they've installed Homeleys on some of their installs.
Okay.
And Ken was on the phone because a couple of times again, it's the installation bit. So for example, pairing it to Wi-Fi. That's what we were trying to work on to improve.
Yeah.
And we've gone through quite a few iterations, like
Oh, this
phones and Bluetooth.
Yeah.
Crazy.
Yeah.
How much
Yeah.
how much it affects the way. Basically, you would think that Bluetooth is just standard. Like it's the same on all the phones.
Yeah. Oh, yeah.
So one of the other things that a Homely can do, and as I said, for the pure kind of like Homely for majority of people is going to be Homely providing you the perfect weather comp without any need to kind of go back to site and tweak the weather comp parameters and do all of that.
Yeah.
When you install a Homely, you'll be able to just run it in that perfect weather comp mode.
Yes.
The other bits that we have been working, so for the past year, I've had a system installed which was, and we've been testing this quite a lot, is the heat pump, PV, a battery, and how do all of those devices kind of interact together, so that they're not starting to fight each other, that oh, I can see the PV, so I'm going to steal all of it, or the battery sees it. And what Homely can do, and where we see Homely moving now is, well, we knew that it was going to be the whole house optimization thing. We wanted to start off with the heat because that we knew that that's going to take a while to get right.
Yeah.
We're there, and we now are going into that kind of. If you have a heat pump, if you have PV, and if you've got a battery or just a PV, Homely can start to optimize your heat pump around those periods. So you, for example, can ramp up the heat pump when the solar PV is being produced, like PV power is being produced. So that's one of the things, and we can interact the whole system.
So just for our listeners as well, I'm looking at a white box in the middle here. That's like that is Homely. There's Homely's like box type thing.
Yep.
That's the controller for that unit or something. Or
that's the. So I've got a MIDI heat pump, and that's the controller for the MIDI heat pump. So we connect into that.
You connect into that
over Modbus.
Does that controller for that that heat pump basically become redundant now?
Kind of, yeah.
So it puts the settings into that. Okay, cool. Yep.
Another basically cable goes into my domestic battery, so I've got 5 kilowatt hours of battery.
Yep.
Then we have a CT clamp over my Zappi charger, which is reading what the EV is doing, so that I'm not discharging my battery into the EV whenever I don't need to.
Yep.
We have Homely cloud system, where basically every day we're downloading new electricity prices for the day ahead. We're downloading solar predictions in terms of how much PV I'm going to be producing for the next day, and also using some of that information as well for the solar gains. And the battery already knows how much PV I'm producing, so we can track like all that historical data. And at the moment, what we are looking for is actually some people who are willing to go on that journey with us, because as I said, we've had a system that we've been testing for a while.
Yeah.
We know that we can control the heat pump really well. But as a whole system, we need to see more people have all these systems connected.
Yeah.
And if we have a website where you can sign up to become like an alpha tester. This is for people that very much want to be at that forefront of kind of what we're building.
And how do they find that website? Homely.com? Or?
So hopefully we can share it somewhere. So if they go on homelyenergy.com and they can contact us, and we'll send them a link. But it's homelyenergy.com /hems-overview.
Okay,
I think
we'll pop that in the description.
So I think that's remote commissioning, again, is one of the things that is really useful, because you can put in the parameters into the heat pump without needing to actually go into the installer settings. I think for volume solutions, basically where we want to be installing a lot of heat pumps, it does happen when like typing in those parameters, sometimes you might miss something, and this way you can make sure that it's done for you through the Homely app. If anyone has changes these in the operation, you can actually just resubmit them again. From the Homely side, you can also see these. So on some heat pumps, they allow us to see the parameters that are inside them. So as an example, the hysteresis setting on the hot water temperature, we can change those remotely. So I've spoken before, we can see Modbus errors. So I say that you get a low flow error, and the customer calls you up and basically says that I don't have any heating. You can go onto our dashboard and check that it's a low flow error and actually go to site prepared. In terms of what to bring, so it saves you time on site as well as the tell the customer potentially how to fix it for a brief moment.
Going back to the hysteresis and the hot water, do you adjust that in a learning way?
Not at the moment.
Okay, but that'll be something that's coming anyway as well.
Yeah,
all of these things will be added.
There is stuff that it is still to add. So hot water, for example, optimization. There is some stuff that
flow temperature for hot water. Are you doing that yet?
No, not at the moment as
That's
well.
a thing.
It is a thing. It's very interesting how it affects some of the other behaviors of the heat pump if you adjust that. So kind of like because depending on the size of the unit, depending on where your hot water temperature is at the moment, maybe you want
and
to
your coil size and if it's stratified or not.
All of those things are very, very important. And on the hot water side, at the moment, Homely is quite simple because hot water is something that you definitely don't want to wake up to, like a cold hot water tank. But in the future, we will do a little bit more. So kind of throughout the summer, when you have a lot of PV produced, like when you have a lot of PV falling onto your house, you want to make sure that, for example, you turn on your hot water reheat during the times when the sun is
not your immersion.
Not your immersion, exactly. And this is where you're going to get your
So you got PV diverter there anyway. Stop buying PV diverters. Just get Homely.
Maybe not the message
When it
just
comes.
quite yet, but it can help you kind of shift those loads to the periods. It's really difficult with PV to kind of. You're not going to be able to, with the PV diverter into the hot water tank, you can soak up quite a lot of that power. Whereas a heat pump needs to run at least at a certain capacity. So there is some still thinking to do. But you can do that there. In terms of the operation, I've already spoken about some of the the way that it kind of operates, and I've shown you a graph where we can show that in real world that this is actually working and it is actually a real thing. Installation, super simple, as in like so on the media you got 2 cables that are going into the media controller and that's it. That gives you the wireless stat as well, which is a big selling point for some as well. So as an example on Samsung, if you wanted to use the Samsung controller, you would need to wire it into the living room, which is
which you really wouldn't want to use the Samsung controller.
In our case, we can still do the flow temperature control and with a wireless internal feedback. So that's good because you avoid the cabling in the house. We have some videos online where you can watch, like on our YouTube channel, Homely by Evergreen Energy YouTube channel. You can see the installations.
What? Actually, no. I'll ask at the end. Keep going.
And that's it.
Cool.
That kind of.
Oh, how do people purchase? Homely?
So at the moment, we've decided to go for. So we're setting up with distributors. So at the moment we have.
So you are going through distributors.
Yeah, okay. we're going through distributors, and I think that that's the best way to do it because then the whole kit arrives at the same time. To customer site.
Hopefully.
But in terms of if we're not set up with like if you don't have an account with that distributor, we can sell directly. It's just that we do want to work more with distributors, and if any of the distributors are listening, get in touch and we'll get you stocked up because from our perspective, we want to make sure that all that kit is basically purchased at the point of the installation. You want to get a home.
Well, you don't have to go to multiple places to buy. That's more important, I think. You just want to get your pack from a place, and So, Homely's you really, right?
It's the team.
Now it's but it started off as you for a very long time. When did you become part of Evergreen?
That was where I said Homely Energy, and that was the first name that we had.
Oh, right. Energy. Okay. So that's when Homely Energy was born, when Evergreen and
no, so
you...
Homely Energy was the company that I set up in 2018.
Right.
And then 2020 we got acquired by Evergreen Energy.
2020. Right.
And then we became Homely by Evergreen Energy.
Right. Right. Okay.
That's where the confusion came from. And like I still sometimes accidentally say that.
How did that? What, you were looking for someone to invest to develop the thing, or did they approach you?
We've been so at the beginning. So when I started at Homely, invested everything that I had. Maxed out a couple of my credit cards, and that was basically I've taken a punt. It was my PhD days. I've had I think I started off with 15k just to start testing some stuff out. So invested all of that, then managed to get an investor, a really cool guy who helped us manufacture some of the Homelies, like the very first Homelies. But even from the outset, we started going to these working groups in Manchester, and I've met Evergreen Energy and the guys from Evergreen Energy. We got along really well. We started talking about things. They were doing the installation side of the business, and they also have a virtual power plant. It kind of we fit really well, and I knew the demand side response and the virtual power plant is a big part of the future, and that's definitely where we're going to go.
Yeah.
Once when we had set up Homely Energy, then we were working with this guy as well for quite a while. Then realized that there is so much to do, and basically it's better to kind of not reinvent the wheel and just use the people who have the expertise.
Absolutely, yeah. And I think this whole transition, all of this stuff, it's all about partnerships. Like, like I'm sure we'll probably be working together in some capacity or another in the future.
Hope so.
Because what you're doing is exactly what I would do if I was going to go and do that thing. So, well done. I think we've definitely used up enough of the time there, but that was amazing. Really interesting story, and I like the fact it's backed by you. Very interesting character. Okay, guys, that's it for this one. If you want any more details on the kind of technical sides and you want to understand this more on a deeper kind of level, take a look at our courses on heatgeek.com or courses.heatgeek.com. And if you've watched this on YouTube, make sure you like and subscribe. If you've been listening on audio podcast, or if you've been listening to the podcast, I'm not used to saying this bit.
That's okay, you can say
If you leave this in, if you've been listening to this on the podcast, make sure you subscribe as well. That's the word for podcast.
Follow the podcast.
Follow the podcast. Sound really old now, don't I? I don't listen to podcasts, but you should listen to this one.
You sound like you've never done an outro before in your life.
And I think that's it. See you in the next one, or listen on the next one.